Hey kids, so today we're going to be discussing potential and kinetic energy. Now, first off, we have to answer the question, what is energy? Well, energy is the ability to do work. Now, what is work? Work, in terms of physics that is when force has the ability to move an object. So, let's see an example of that quickly. Okay. Let's say that you have Super Mario Bros. 2 sitting on a shelf, and someone comes in, pushes it on the floor. That's an example of work, because gravity is a force, and the gravity is having an effect on the object, making it move. In this case, fall to the floor. So that's what work is. But now we have to get back on track of what potential and kinetic energy is. Potential energy is when something has energy due to its location. So first, let's see an example of that. Okay, let's say you have a putty knife sitting on the edge of a coffee table. Now, this object right now is high in potential energy because it is sitting up at a high height and will fall if it falls off. So if you knock it off, it now has 0 potential energy because it's on the ground and it can't go any lower. Next, we're going to discuss kinetic energy. Kinetic energy is energy of motion. This would mean that if an object is moving at a pace of, say, 100 miles per hour and hits another object that is completely still of the exact same weight, the object that was moving would stop at impact and would cause the object that was originally still to keep moving at 100 miles per hour. Now, unfortunately, I do not have an example to show you because I cannot find 2 spherical objects of the same weight to use. However, I can demonstrate kinetic and potential energy both through a roller coaster I built. Now, with this roller coaster I built, be aware that it's not built to scale. If it were built to scale, then it would be, the starting hill would be approximately 700 feet high. Now, if you're not quite sure how high 700 feet is, that's the height of 60 elephants. And I can show you what that looks like. This is the height of 60 elephants. Anyway, onto the roller coaster. Whoa, 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 whoa. That was going pretty fast. Let's watch that in slow motion so we can see what was going on a little easier. Now, as it drops down the hill, it increases in kinetic energy. As it goes up the loop, it increases in potential. And then as it goes down, increases in kinetic. As it goes up this hill, it increases in potential, because it's rising in altitude. And then as it goes down this little curvy hill, it will increase in kinetic, because it's gaining speed from going downhill. Now, for the remainder of the roller coaster, it will stay at a consistent high of kinetic energy, and will have 0 potential energy, because the only thing slowing it down is friction, which I discussed in my previous project. That was a PowerPoint. Kind of boring to watch this thing come to a complete stop. It's almost there. Stops about partway around the curve. And it is stopped right about now. There you go. So there you have it. Now you know a little bit about potential and kinetic energy. I hope you liked this video on explaining the two. Up next, the A-Team.
In 1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire